Okay, today is June the 25th, 2016. I've punched a few holes here. Output transformer goes here. Power, output. These are where the 4 tubes are going to be. They're all actually the same size, but I haven't started punching them yet because I'll show you what I use. I use these little green lead punches. This is a 1 1/8. Let's see, the one I was just using was this 3/4 one. These things nowadays, they're kind of pricey. I've had these things for most of my life. They'll last you darn near forever. This is a 3/4 inch, so you drill a pilot hole. In this case, for this one, you drill a 3/8 inch pilot hole. It's oftentimes a good idea to use a little ringer and make it just slightly bigger, because what happens is when you punch it out, you end up with these little things right here. These little, this is the pilot hole, and then this is the part that it punches out. You don't want to make this hole too large, because then you could get the thing off center, and your tubes wouldn't be aligned then, or your holes, whatever going in these holes. But when it wrinkles up like that, if it's not just slightly larger, it's the devil to get out off of this bolt right here, because it gets pressed up inside these things. It gets pressed up inside this this section right here. So you put this in the top, you drill a hole and you put this in it like that. Put this on from the bottom side, and you screw it on, and you can see it's got 2 sharp edges. And they're actually still very sharp after I don't know how many decades. And then you just start tightening this thing down, of course, at the top with this, with a wrench, and this will bite into it, and just pull it right through. Through aluminum like it was paper. Now these things come in a bazillion different sizes. Like I say, they've become extremely expensive nowadays. They always have been, actually. This is a 1 1/8. Takes another 3/8 inch pilot hole. It just punches a bigger hole. Exact same concept. The sockets I'm going to be using for the output tubes are these ceramic guys, and they're a little bit different. You have to cut a hole so that you can just get it in. And if you start measuring these things very carefully, you see that it's right there. You can barely get it through. I don't know if you can read that. That's 1 1/8 inches. 1 1/8. And for my European friends, that is 28.75 millimeters. So there you go. Well, then anyway, you punch that 1 1/8 inch hole, and then you wrestle this thing down in there just a little bit. You may end up having to take a deburring tool. You need a lot of little tools. This is a deburring tool. So it's got a sharp metal tip on it, and you do this. That takes all the burr off of it. You do that on the underside and the top side, so you can make the holes nice and smooth. For small holes, I use a drill bit. This is a 1/2 inch drill bit. I actually dipped it in plastic a long time ago just to hold it and to identify that's what it is. And for small holes, you can just put it there and twist it and cut the burrs off. You want to do that. You want to take your time. See, what I'm going to do with this one is completely punch it and then paint it. So that's why I say if I mark it up, I'll just wipe it off with some solvent. Okay, now for these holes right here, see, this is where the transformer wires are going to go through. I'm not going to put them in yet because I'm not through punching it and painting it, but then I use these rubber grommets that you put into these holes right there like that. Kind of fight that in a little bit. And that way when your wires go through it, they don't get chafed on the side of the metal. And so I put 6 in there. I'll drill the 4 holes for the ceramic sockets, and then for the 6SL, 6SN7, I'm using exactly it actually uses exactly the same hole socket. Although this one is just ever so slightly smaller. This one comes out as 1 7/64. So it's 1/64 of an inch smaller, which makes it fit very, very nice. It just goes in there like it was made for it, because it was, for a 1 1/8 inch hole. And oh yeah, after you put these in, the way that they stay in, because you can see it doesn't, these have little ears on it, so you have to drill holes to mount them, which is okay. These once you put these in the hole, you put this little, fight this little wavy washer over the bottom of it. Of course, I got to clean it off really nice. You stretch and fight, and finally you get all this thing over it, and there's just enough of a gap in there that it'll click and it'll finally lock in, and it's pretty darn tight. It won't fall out. So that's a little progress right there. I'll probably finish this up tonight. Got to get the holes over here. I've got a bunch of nice hardware selected. Use some black screws. You know, a lot of this stuff right here actually came off of, was salvaged off of an old General Radio instrument. Really nice stainless steel stuff. This is not stainless. I don't remember what that came from. But this is, I don't have all black, but we'll see. Some other stuff, some other nice stainless stuff off of the different instruments that I salvage. So that's a wee bit more progress. Let's set this thing down, and oh yeah, see, like right here, you have to have a lot of parts. Have a big assortment of grommets and feed throughs and all that kind of stuff. So you got to have a bunch of that kind of junk. You also need these are actually electrical stuff. You can get fancier ones, black things, little plugs like this. Some people call them goof plugs. In case you punch a hole in the wrong place, you go, oh man. You can fill up small holes with just screws with nuts on the other side, and it looks pretty normal, because it's pretty hard to make an amplifier with that many holes and that much work involved without making some tiny mistake. So let's move on until we get to the next point, and I'll start again. I will show you punching one hole for those of you that are not familiar with these type of hole punches. You just, as I say, here's the sections right here. The screw, the top section, bottom section. You put it through the hole that you drilled. You screw this onto the bottom, and then with some sort of a wrench, just turn this thing. You can cut some really thick stuff with this if you've got the strength. This is really easy, but if you try to cut panel, wow, okay, perfect hole. Now this one I don't have to drill a little mounting hole. This one's going to have the washer beneath it. I'll do the same down here for all these tubes, and then I'll have to put the socket in and mark the two little holes for like number 632 screws. And then you take this little guy apart and take good care of your tools. You'll love these things. Like I say, they'll last you a lifetime. This is the piece that you punched out. So there it is. Just like the little ones, except they're bigger. Keep them greased, and you always get dirty, of course. But you keep them greased up and clean, and there you go. Okay, continuing to think this thing through for, in particular, new builders that's never built anything like this. I printed the schematic. This is the amplifier schematic that I will be building. It's the Acrosound ultra-linear 6L6 circuit using the TO-300 transformer. I'm using the TO-305, which is the same transformer, but 305 has two 500 ohm windings over here that we're not going to be using. Two 500 ohm secondaries. Just not going to be using them. And what I'm trying to do here is do some physical layout. For example, I labeled the pin numbers on the tube, and it's grid plate cathode, 1, 2, 3, 4, 5, 6, then the filaments on 7 and 8. So what I'm trying to accomplish here is a mechanical flow, if you will, from pin 2 and 5 over to 1 and 4. And if I put the tubes in this way, so you count the tube socket from the bottom. So this is 1, 2, 3, 4, 5. So I would have these pins on this side flowing this way. So those two big 0.25 capacitors will come over to this one, and they'll go into pins 1 and 4. So we count here 1, 2, 3, 4. 1, 2, 3. So I'm going to orient this one this way. See how what I'm talking about? The pin goes this way, and this one goes down. And here on the other side, it's actually just the opposite. This one would go up, point this way. This one would point the other way, to have things mechanically flow. That's actually pretty important. You really want to lay this out as best you can, so that the physical layout, the mechanics of it flows, so you don't have wires coming out one side wrapping around, as best you can. Sometimes you can't avoid it. Similar over here, the plate leads. Well, let's start with the filament. The filament's on 2 and 7, so that's 2 and 7. That would be right here. So what I'll have to do is come out with 2 wires, probably over to 2 and 7 here. Same here to there. These will be wired 7 and 8. I would take 7 and 8 and run it around the chassis to there. Then back here to the chassis, around to there, or to there. But actually what I think I'm going to do is I'm going to wire these 2 together, and these 2, and these 2 together, and these 2, and then run 2 wires from this pair, or this quad, over to a 100 ohm, I'm thinking about this, over to a 100 ohm hum balance pot right here. See, in the transformer, this power transformer is going to sit right here. And these 2 green wires are the filament. That's what's going to light it all up. This is a 6-volt, 8-amp filament supply. I'm thinking about putting it in the middle and distributing the filament voltage that way and this way, and that way and this way. Some symmetry to it across this pot with a center tap to ground, so it'll be a, this will be a hum balance. I don't exactly like the idea of having that pot there in the middle, but I guess that could be okay right there. So there's another piece that for those that have never built to think about. It's always good to think about it before you start building. Oftentimes I don't think about it enough, and I run into, well, I wish I'd have done it slightly different. And I may do this time. It's pretty easy to trick yourself and think you got it all figured out, and then you go, oh well, that didn't work quite the way I wanted it to. But in either case, I got to clean all the sockets off, and I'm going to mount all of the tubes this way, and all of the 8 pins with the key that way. So there's another piece. You might wonder, how am I going to get all of these holes in exactly the right place? Well, I'm going to do it as simple as possible. Of course, I'm going to flip the socket upside down. See, it fits it pretty perfectly. I'm going to eyeball it. I'm going to mark these things. But before I start drilling holes, I am going to use a T-square to make sure that everything is parallel and perpendicular, because just little bits off here and there will make you look at your amplifier and say, oh, I should have slowed down just a little bit. That's a little crooked. So eyeball it, mark it, measure it, make it straight, and that's how you get those holes with no pain. Okay, made real progress tonight. We got all the holes punched. This is the rear of it. The front, there'll be nothing on the front. Input, left and right, gain pots, all the components here. This is the rear. I kind of modeled it a bit after the Dynaco ST70. This is the, I'm going to put actually everything on here. These, I'm using the old style strips. This is an on-off, slider on-off switch. Goes in there. Of course, the other way around. A You see right there. I'm going to clean that off. I'll show you what I do with that. I use a little bit of solvent here. Kind of wet it a little bit. And all this stuff will wipe right off. So you clean it up. You don't need to watch me clean everything up, but you can see that the magic marker comes right off. I'm actually using chloroform to clean it. Then I'm going to have to clean this thing up real good. I'll just give it a light brush. I'm going to be painting it tonight, letting it dry. But I'll basically assemble it without any hooking anything up, of course. Let you see. For those that haven't started building yet, here's a basic set of building tools you will probably need. Of course, T-square, measuring, accurate measuring tools. I use this, I think I've already pointed out, to deburr it. You need all sorts of different size files. You'll need a lot of files. Deburring tool, of course, screwdrivers, markers, etc. A little tool to a reamer to ream the hole out. Sometimes you need it just slightly bigger, not a whole drill size bigger. So you can touch it up with that. I did not have to use this. This is a nibbling tool, in case those who are not familiar with it. See this thing right here, when you squeeze this, see how it pinches down? That's in case you want to cut a big square hole. And if you want to cut a big round hole, you use, well darn, I cleaned up. Look right in front of my eyes. Oh yeah, you use a tool like this. You loosen this up with an Allen, this thing slides in and out. This would be the radius that it's cutting. Kind of dangerous. You can hurt yourself if you're not careful and ruin your chassis. I've cleaned up all the tube sockets. They're all sparkly clean. I can't think of much else besides cleaning it up. I'm going to show you some old style way of doing drafting. I'm going to make a nice schematic of it. This probably is not the one I'll go with. But I have a little drafting table. It'll stand up. If you're not familiar with drafting tools, this is called an erasing shield. Of course, you got the templates, naturally, to draw things. Here's the original schematic. I don't know how many of you have ever seen an electric eraser like this. Works marvelous. You turn it on and you can just, it just takes it right off. An electric eraser, that's probably 1950 stuff, but I still use it. I don't do a lot of drafting. I do have electronic drafting programs and I know how to use them, and I have used them many times, but sometimes you just want to draw it. Another really indispensable tool is the Dremel. Oh yeah, I can't live without this. Sometimes the small ones are better than the big ones, because if you want to cut small holes like that hole for the slide switch, you need something like this, and then you got to file it and file it. Do the very best you can to get it straight. Okay, well, I think that's it for tonight. I'll put these together and post it, and tomorrow we will have a nice painted chassis. Well, no, I think I'll assemble it and take a look at it just to make sure everything looks whoopee, and we'll go from there, and then I'll pull the components right back off and paint it. Okay, to finish this little guy out for the night, this is basically what it's going to look like. I've modeled it with 6L6s, the GE stuff, 6SL, 6SN, 6SL, 6SN. The audio flow is this way into there, and this way into there. The inputs are over here. Seeing the outputs on the back. I don't have everything tightened down real tight, because I'm going to package it all back up, put it in a container where I can get to everything. I have some screws. I'm really picky about things like this. These little screws right here are a flathead, and seeing these are a Phillips. I personally like Phillips better. Whoops, see, I don't have it tightened down very well. But that's okay. Just making sure everything fits. Here's the back side. Looks like that. I'll have to put the screws back in there. AC, fuse, and that's going to be an on-off switch right there. I don't exactly like that hole. I may be able to find a mask for it, just to tidy it up and make it look perfect. So that's it. I'm open to suggestions. If I've done something really stupid here, you know, let me know before I drill another hole. There probably is another couple of holes that will have to be drilled in it, and they're going to be right here in this area and here for the components of these. I may need one like a terminal strip there and there, maybe there and there. So I may have to drill 4 more little small holes, you know, for 632 screws. Well, that's it. I hope you enjoy, guys, and we'll have this thing running here to maybe another week, and hopefully it'll do a marvelous 25 watts per channel. If it does, I'll be very happy.